Hello guys, welcome to today's class. My name is Bram Paul. Today we will look at the second part of control statement. Remember yesterday we introduced a new topic called control statement and we define it as statement that alters the sequential flow of our program during execution. All right. And we mentioned two types, selection statement and repetition statement. Now yesterday we were able to cover selection statement. And we define selection statement as statement that causes the program to execute some line of code and omit others due to some certain conditions. So today we will look at the second part of it, which is a repetition statement. Repetition statement are statements when encountered during program execution will force the program to execute some line of code for a fixed number of time or until a particular condition is met. All right. In programming, this repetition statement is also called looping. All right, because the program will continue running in a circle. All right, until a certain condition is met. So today we'll look at a repetition statement. Repetition. All right. So the first one there is while loop. Second one is called do while. Then the third one is called for. So we'll start with while construct. So I'll come over here now and delete some things here, or delete all these things. Okay, I want to give us a general construct of a while loop. So let me just include it here. Okay, this is the general construct of while loop. Start with while, then in bracket we have boolean slash relational expression, then statements. So what it means now is that after the while, if the expression in the bracket result to true, then execution will enter into the loop body and execute. All right. But anytime the expression in the bracket on line 36 results to false, then the execution will break out of the while loop. So let's take an example. Say sorry, compute or write a program. Write a program to compute. Let me just say sum of the first, say n integers. N integers. Okay, that is the statement of the program. Sorry, statement of the problem. Okay, so next, I have to declare some variables. Okay, I'm gonna say int sum. I can equate it to say 0 because I'm using it for summation. Where's my equal to? Okay, all right. What next? The number is n. Okay, I'll just say int again, n, which is the number itself. All right. Okay, so I will just say n equal to 100. All right, just say n equal to 100. Okay, so the problem says write a program to compute the sum of the first positive n integers. Then n here now is 100. So if sum of the first positive n, sorry, 100 integers. Okay. So we'll use while loop to solve this problem. So we'll start like this. Say y, now the expression. All right. Then the summation. So what we're saying is that y, what you have in the bracket is true. Execute whatever that's inside the curly braces. What are we computing? We want to sum, I want to sum from 1 to 100. So that's what we want to do now. Okay. So now come here and say sum, which we have declared before, equal to sum again. You get plus what? You see? Now we have to declare another integer and assign 1 to it. So what are we declaring right now? Let's say okay, let me say count. Okay. Count equal to 1. All right. So what it means now is that we are counting okay. So this equation now will continue to sum, all right, until count equals to 100. You get? So we are starting count as 1. So that means in this loop now, we have to increment count as the loop is running. So I will now come down and say count, you get, equal to count plus 1. Good. You see? So if I should come here now and say true and assign true here, you see that this will now continue to run. All right. This will give us what is called infinite loop. That's unending loop. That is a loop that will not end. So if I should run this program now, this program will continue to run because what we have on line 46 is true, and there is no condition that will alter it. You get? So to give us an infinite loop. So we have to redesign that line so that when count equals 100, then the control will exit the loop. So what are we going to do now? Watch. Count is less than or equal to n. You get? So just see now, count is less than or equal to n. Let me space it. Put space here. Okay. So what it means now is this: we're entering into the loop with count as 1. Then yn is 100. That one is fixed. As we enter into the loop with count as 1, line 47 will execute. Then now assign 1 to sum. Then line 48 will increment count. Count will now become 2. All right. Then before we exit the loop, it will check first the condition at line 46. If count is still less than or equal to n, then the loop will run again. And remember, as the loop is running, the value of count is increasing. And whenever the value of count is increases and the loop runs, then the sum will also increase. All right. So it will continue like this until count equals to 100. When the count is equal to 100, still compare it. If count is less than or equal to n being the 100, now see that the loop also run because the condition will give us true here. All right. The condition on 46 will also give us true. So the loop will also run. You get? Then once the count becomes 101, you see that the condition will turn to false because 101 less than or equal to n being 100 will give us false. So that will now break out of the loop. You get? So execution will now break out of the loop. Okay. So before I run this program, I want to print out the sum. I'll come down here. So I want to run the program now. Watch. You see, sum equal to 5,050. Okay. So the whole thing is running perfectly. Now, what actually happened here? You see, you have while on line 46, then loop body start from 47 down to 49. You see, there is a statement, or rather conditional statement on line 46. All right. That statement, as long as it remains true, this loop will continue to run. You get until it changes to false. Okay. Now we're starting count as 1. And why any remains as 100, any is fixed. And if you check the statement, 1 is less than or equal to 100. That means that statement will remain true as long as the count is less than or equal to n. Okay. Now, as we enter into the loop, you see sum equal to sum plus count. That's how we increment the sum, or rather sum the numbers as we are counting from 1 to 100. Okay. Now, in order not to remain in this loop, because if we leave count as 1, as this loop continues to run, definitely it will result to an infinite loop. You get that's an unending loop. So we have to increment count one by one, all right, until we get to 100. All right, because remember, once count is 101, then the statement on line 46 will give us false, and the control will break out of the loop. So as we increment count, the loop will also compare again. Then it gives us true. Then the loop body will run. You get? So it continues like that until we get to count equal to 100. So that count equal to 101. And when the line 46 compares the value of count and the value of n, you see that count is now greater than n. Then the whole expression will give us false. Then control will break out of the loop. Okay. So I want to print out the value of sum and value of count inside the loop. All right, so that we'll see what is happening. All right. So in order to do that, I'll first of all reduce the value of count. That is being value of n. All right. Let's say 10. Okay, 10 is enough. So I'll now come here and say, okay, let me copy this statement. It's difficult typing here. I'll come here and say count equal to count. Okay. Again, I'll say, okay, I need to paste first. So let me run the loop now, or rather the program. Okay, as you can see, count equals to 1, sum equals to 1. Count equals to 4, sum equals to 10. Count equals to 7, sum equals to 28. Count equals to 10, sum equals to 55. Remember, this count is like the individual n. You get the number we entered, which was 10. So we broke it down from 1 to 10. All right. So as we count 1, then we'll sum it. We count 2, we'll sum it. We count 3, remember, sum is the summation of the previous and the current nth number. Okay. All right. So I'll go back. Now let's go to the problem statement on line 40. It says sum of the first positive n integers. All right. The problem statement didn't say we should sum the first positive 10 integers. You get it? But say n. That n means any number at all. All right. So that means you have to reformat this particular code. Sorry. That means we have to reformat this our code. All right, in order to allow the user to enter the value of n. All right, not just hard coding it, because the way we design our program right now, on line 1243, we just hard coded the value of n. All right, so we have to reformat it in order to allow the user to enter the value of n. All right, so that will give you our program that flexibility. All right, so that user will not be the one in charge to control the value of n. So remember our our old friend, which is a scanner. All right. So we use scanner object to read data from keyboard, and we have already defined or rather imported scanner on line number 1 here. It says import java.ut.scanner. So with that statement, we have a scanner class to work with. So I will now declare the class and create the object up here. I'll now say scanner, you go this side. Scanner sc equal to, say, okay, new. Remember, we are creating object. I normally create object with new. All right. Scanner, my brackets, open and close. Remember, we'll pass in this here system.in. All right, as an argument to the scanner class. Then at the end, we'll place our semicolon. Okay, that marks the end of that here statement. Okay, now we have created the scanner object. The next thing now is for us to read in the data from the keyboard using the scanner object. All right, and before now we have treated so many of the methods that is used for reading data from keyboard. Okay, so today now we'll use next int. All right, next int to read the data from keyboard. So I'll come here. Remember that next int is the method of the scanner object, or rather scanner class. I'll now say n. So I'm going to remove this 10 now. So that n will be read from the keyboard, which is the integer we are summing up the number on. Now say n equal to sc dot next int. Okay, this is a method, so we have to put bracket and a semicolon. So with this now, we will be able to capture whatever the user is entering from the keyboard. With this statement now on line 48, we have n equal to sc, which is the object, dot the method that reads in data from the keyboard. But this time around, we are using next int. Next int means integer. That is, means that this object is expecting integer to be read from the keyboard. So that means we have to instruct our user to enter only integer, that is numbers, digit. So any other thing would cause error. You get, because we are expecting only integer. Come up here and say system dot out dot print. All right, this statement is just like an instruction. All right, I'm sending this output to the user to instruct the user to enter digit, all right, to be read in. Okay, I'll now say the instruction now will follow like this. I'll now say please enter positive number. Okay, so all right, so this statement now on line 47 will instruct the user to enter positive number, and once the user enter the number and click enter on the keyboard, or rather the phone screen, line 48 will now read whatever the user has entered and store it in n. You get? Okay, so we'll now enter into the loop without a value. Okay, so I want to run the program now, and this time around I want to pretend as the user now. Program is running. Okay, see, please enter positive number. Okay, I'll enter 5 and click enter. You see, very fast, very fast. I'll go back and run it again. Please, okay, please enter positive number. I'll enter 100 and click enter. Very fast. You see, remember this scan is not needed. We just put it here, all right, just to explain some certain things. You get? So the sum is, in fact, what is needed in this program is the last sum. You get the sum at count equal to 100. That is what is needed from this program, the sum of first positive n number. Okay, so as you can see now, our program is responsive, meaning that the user is not the one in charge of the program. You get, the data we are using for computation is now coming from the outside. All right, so whoever that is running the program now is now the person in charge. So program is now responsive. Okay, now to wrap it up, you see, line 50 to line 57 is what we call the looping construct, or rather the loop construct. You see, when the user enter say 20 or 100 or 50, then we enter into the loop with that value that is coming from the user. Now, before the loop will run, there is a statement on line 50 that says count is less than or equal to n. Now, if that statement values to true, we enter into the loop. You get into the looping block and execute whatever that is within the loop. After executing the looping block, then the program will still come out to check if that statement on line 50 is still true. That is, if the count is still less than or equal to n. If it is true, then the execution will enter into the loop again and continue to execute, continue to run until the count is equal, sorry, until the count is higher than the n. All right, once count is higher than n, that means we have not exceeded the number that the user entered. So then the statement on line 50 will turn to false. In that case, the loop will no longer run. You understand? Now, take note of this statement on line 54, which is count equal to count plus 1. It's very important. You get? It's very important because that is what is controlling this loop. You get? It is incrementing. If we omit that statement, then we'll have what is called infinite loop. That's a loop that will run without ending. All right, an unending loop. So you must make sure you put that statement. That is something that will eventually make the loop to stop running, because as it is increasing, once it gets to that particular number that user enters, all right, and increase by 1, then the statement on line 50 will turn to false. Then the loop will break out. Do you get? All right. So that is that. The next thing here now, we have a do while. We just treated this a while loop. You get? So next now we treat a do while. This particular is next now. Okay. So go back now. Now while loop and do while are almost the same thing, right? The only difference here now is that we will change the position of this y. You get? So this y now have to come down. This statement now have to come down. Just watch now. Okay, let me comment out this y. I want to comment it out. First, I'll copy it. I'll comment it out. I'll copy it. Let's copy. Okay. Now I want to comment it out. Remember our multi-line comment marker. Okay. So I'll paste it here. So that when I change it, you will see everything. Now, I said that the difference between do while and while loop is just the position of the while statement and also inclusion of do. So here now I'll copy this y. Watch. I'll cut it out and place it here under. Then here now I'll put do. All right, good. That is just it. All right. Now in terms of execution, you see, when we had y at the top here, the condition must evaluate before the execution enter into the looping construct. But for do while, you have to run the loop once, at least once, before the condition evaluates. I want to run the program right now. Okay, enter first positive number. I'll just say 10 and click enter. You see, it's giving me the same result. You get? While loop, do while are just the same. The only difference is the position of the y and also inclusion of the do. All right, because here we just added, what is this? Okay, here we just added do here and brought the y down. Then in terms of execution, like as I said before, the loop block is executed at least once before the condition is checked. All right, for do while. But for while loop, the condition must be checked first before the execution enter into the looping block. Okay, so with that, we are done with do while. Next on queue here now is for. All right, so we are still going to make use of the same problem statement. Okay, so I'll go under here now. Okay, let me comment out this particular one. Okay, for statement, it goes like this. For first, let me say initialization, initialization. All right, so this is the general construct for loop. It says for bracket open, initialization, semicolon, expression, semicolon, increment, then bracket closes, then curly bracket open, statement or block of code, then curly bracket close. So that is the general construct for statement, or rather for loop. Remember that expression is either Boolean or relational. Okay, so example, we will use the program statement up here that says sum of the first positive n integers. Okay, and we've designed, sorry, we'll declare some integers here. All right, so let's go ahead and use for statement. So I'll just come here and say for wash for bracket open. The next thing there is initialization. Okay, you see, when we treated while loop and do while, we use count for increment, and we initialize the count before we enter into the loop, or rather before the conditional statement. But for statement, the initialization and increment are included in the bracket, in this bracket. Let's say I. Okay, let's use I. So I have to declare it first. Say int I. So this is the declaration of that I. I know that for integer, when you declare an integer, you get, when you declare an integer without assignment, that integer is automatically equal to 0. But now, since you are starting with count equal to 1, or rather I equal to 1, I also include the initialization here after declaration. So I will initialize it to 1 and say equal to 1 and my semicolon. Then the next thing now is expression. Remember before we said we use count is less than or equal to n. So this time around we're using I. And is this I now that will increment up to the number of n, and I exceed n by 1 in order to break out this loop. So I'll now say I less than or equal to what? N. Remember, n will be entered from the keyboard by the user. I'll now put my semicolon again, and it say I plus plus. That is I equal to I plus 1. Okay, but remember, this I plus plus will run at the end of this loop, or rather after the execution of the last line in the block. So I'll open a curly bracket here and close it. So on line 77, we have a statement that says for bracket open int I equal to 1 semicolon I less than or equal to n semicolon I plus plus bracket close, then and go curly bracket open and close. Now the first statement there, because we have 3 statements separated with a semicolon inside that bracket on line 77. The first statement says int I equal to 1. All right. So in that statement, we are declaring I as integer and initializing it by assigning 1 to it. Then second statement that says I less than or equal to n is the statement that will control this loop. All right. That is the statement that we tell whether we are to enter into the loop and execute whatever that is inside the loop or not. So anytime if n is less than or equal to n, if I is less than or equal to n, that means that statement will give us true, and whatever we have inside the loop will execute. But if anytime it gives us false, we'll break out of the loop. The last statement there, I plus plus, is an increment statement. It always increment I as the program executes. All right. So when the program runs, at the end, it comes back to execute the loop again. They check the condition, but before it checks the condition, it has to increment I. Then now check the condition by evaluating the statement at the middle. All right. Now, for this line 77, the statement that says int I equal to 1 will only run once. That's the first time. All right. Then the second time, before the loop will be checked, I will be incremented. You get? So as we enter into the loop, the initialization will take place, then the conditional statement will check or rather evaluate. If it gives true, then the execution will enter into the loop. We start evaluating the last statement that says I plus plus. So at the end of the loop block, all right, then before checking the condition, it will first evaluate the last statement first, which is I plus plus. Then now use it to check the condition before entering into the loop. Okay, now I want to copy whatever I have in the Y statement and paste it in that for loop. That's almost the same thing. We just change some few things. Okay, now I have count and sum. So I have to initialize some variables up here. First one there is a count. We have already assigned count. Sorry, we have already declared count as an integer. So I will just come up here and declare, sorry, and assign it to 0. Let me assign it to 0 because I'm using it for counting. Okay, the same thing applies to sum. Let me initialize them to 0. As you can see, I'm writing sum and count on the same line, but there are different statements. All right, because of that semicolon. Okay, now sum is the sum of int. You get? Sorry, the sum of I. That is the sum of the individual numbers. All right, why the count is counting the number of times the loop will run. So what will I do here now? Just sum equal to sum plus count until that statement is okay. So which one is what's our count now? Okay, our count is just I. You get? I'll cut it here, put it up here, or rather before the statement that print out count. Okay, I'll put it here because we are printing out the count. So count is now equal to I here. All right, unlike our Y statement. The count here now is equal to just I. All right, we are not incrementing count here because there is an increment statement here up on like 78, which is I equal to, sorry, I plus plus. So I will now say count equal to I. Okay, until we are good to go. Count equal to I because I is always incrementing. So that means count will also be incrementing as well. Count equal to count, sum equal to sum plus count. Yes. Okay. So we are good to go. So I'll run the program right now. Okay, I'll put 10. Let's see the output. Enter. Okay, it's working perfectly. So you can see, program is working perfectly. All right. There's nothing to explain here. Okay, let me just go through it once more. On line 76, we initialize count and sum to 0. Then line 78, we started the looping construct by saying for int I, sorry, for bracket open, int I equal to 1, I less than or equal to n, then I plus plus. Please note the semicolon in between each of the statements. All right. Now bracket close, curly bracket open. On line 87, we'll close the curly bracket. Okay. Now, like I said before, the first statement on line 78 is initialization, and it only runs once. All right. Then, before we enter into the loop to execute, we'll evaluate the second statement on line 78, which is I less than or equal to n. If that statement gives us true, then we execute whatever that is inside the curly bracket, which is from line 80 to line 86. But if I less than or equal to n gives us false, then we will not evaluate the loop, or rather whatever that is inside the loop. All right, but since we are starting I as 1 and our n is any number that user enter, So if that number is less than, sorry, if that number is greater than 1, then the loop will eventually run. Okay. Now, if we get positive, or if we get true value from this, from the middle statement, then we will now execute the loop. All right. At the end of the loop, that is when we will now come back to execute the last statement on line 78, which is I plus plus. So the first time we enter into the loop, that statement does not execute. Okay, so if we come back, then we check. Sorry, first we increment the I and omit the first statement, then run the second one. If it give us true, then we'll run the loop again. You understand? Until that statement gives us false. That is the middle statement on line 78. Anytime it gives us false, then we'll break out of the loop. So that's how it works. So I now, or rather count now, is now counting a number of times this loop is going to run. All right. So that is it for loop.